Anyone can
Chapter
be closer.
16, random variables.
I have a feeling it might not happen.
It's not looking like it.
Wait,
All right, a giant X denotes a random variable.
Pretty big.
Well, it's like bolded and capitalized, so I have to make it
this
really
font
big.
so big and stuff?
I don't know. You don't need
What's
that today.
inside of this?
I have no idea.
You think shaving cream?
It's shaving cream.
All right. Denotes a random variable whose numeric value is based on the outcome of a random event.
Why are your things going on?
It always
It
does.
happens all the time.
Very often.
Sure.
Thanks. Thought I had my notebook with me. Not my big one.
Well, hurry up, Nathan.
If we can list
Casey doesn't have my ball.
all possible outcomes, it is a discrete, does that mean secret, random variable. Nathan missed my joke.
What was it?
I said it's a discrete random variable. It's not a secret.
At least he has an excuse for why he's oblivious this time.
If we can't list all outcomes, it is continuous. So if we can, it's discrete. If we can't, it's continuous.
What does discrete mean in this context?
Like a specific amount.
Okay.
Like a accountable amount, basically.
Specific, kind of.
Sort of, yeah. A probability model is the collection of all possible values and the probability of each. The expected value of a discrete random variable we multiply each possible value by the probability it occurs and find the sum. This has a formula. Mu is equal to E of x, which is the expected value, which is the summation of x times P of x, which is the probability. We'll look at a quick example of this. Life insurance payout. A company pays $10,000 for death, $5,000 for disability, the probability of death is 1 in 1,000. That's comforting. Disability is 2 in 1,000. And so we're going to look at a probability model. So we've got 3 columns. So we're going to have an outcome, we're going to have a payout, and we're going to have the probability. All right, so there are 3 possible outcomes, right? We have death, we have disability. What's the third one? Neither. Okay. Are you to the example?
Yeah.
Okay. All right, so the payout for death is $10,000. The payout for disability is $5,000. And neither is $0. So nothing's wrong with you, you get no money.
We don't get money for death either.
Fair. You're just chopped liver at that point.
What's the point in getting
Maybe literally.
money when you're dead?
To pay for your bills.
Nothing.
All right, the probability of death is 1 in 1,000. Disability is 2 in 1,000. So neither is 997 out of 1,000. So if I want to look at the expected value that the company can expect for a payout, U is equal to E of X, which is going to be 10,000. Okay, so it's the payout times the probability of it happening, which is 1 out of 1,000, plus the payout 5,000 times the probability of it happening, so 2 out of 1,000, plus the payout, which is 0, times the probability of that, which is 997 out of 1,000, which ordinarily I wouldn't write that one, but for the sake of you seeing this, I will. And that's going to be equal to a lovely $20. So they can expect to pay out $20. So the expected payout per customer is $20. How far down can I go, Nathan?
I don't need the chart.
Okay.
So.
All right, standard deviation. Oh yes, it's back. Won't be gone for long. Calculates the expected variation we find the variance by squaring the difference between each outcome and the mean, which is expected. So the variance formula, V of x, is equal to the sum of x minus mu squared times p of x, which is the probability. So that's variance. And then standard deviation, which is sigma, what is the standard deviation of x, is equal to the square root of v of x, or the square root of the summation of x minus mu squared times p of x. And so just to go up here and reference, this $20 value would be mu. Okay, just for making sure we see that. So, going back to the insurance company, V of x is equal to 10,000, so that's x, minus mu, which was 20, so minus 20 squared times the probability of that, which is 1 out of 1,000, plus 5,000 minus 20 squared times 2 out of 1,000, plus, in this case, we cannot disregard the 0 one, you have to add it, so I'm just moving it to the bottom because I don't have room to write it up there, plus 0 minus 20 squared times 997 out of 1,000. And when you put that lovely chain of things into your calculator, you get a nice variance of $149,600. So then the standard deviation, we would take the square root of v of x, which is the square root of the 149,600, which is $386.78. Josh, whenever you need to go, you can. Huh?
How much does that last?
Like 3/4 of a page. Do you want to take a picture of this, or do you want me to just send it to you when I'm done?
Oh, you need this? Like,
I'll just take a picture.
That's fine.
I'll see it now. The black.
Oh, my computer.
The one thing, I don't know if you're going to be able to read on there, but
The yellow.
yeah. This is all we're doing today. I'll send you the physics notes,
Okay.
because I think I'm going to go ahead and do the next section of physics notes. TBD, but I think we might.
Alright.
But it's really short and the math is ridiculously easy. So it's force divided by area. Nathan, are you to where I am?
Yeah.
Okay.
See ya.
See ya.
Yep.
Alright. Use the calculator. What's happening? To compute these values. L1 is going to be your outcomes. L2 is going to be your probabilities. X bar is mu, which is your expected value. And sigma is your standard deviation. And remember to find these values, it's one variable stats for L1 and L2. You can add, subtract, and multiply expected values. But you only add variance, not standard deviations. So you must square any constants being multiplied and absolutely never subtract variances. Variation always increases so the expected value of x plus or minus y is e of x plus or minus e of y. But for variance of x plus y, it's v of x plus v of y. Continuous random variables. Can take on any value. They always have means or expected values, mu, and standard deviations, sigma. Got excited, I thought I saw a snowflake, and I think it was a bug. Maybe it is. There's another one.
Snowflake or a bug?
I think a snowflake. I see a few. I don't know. Not a lot though, and they're flying sideways, so maybe they're not. I don't know.
I think I've seen it too.
But I don't know what it is. And they're floating upwards. I don't think those are
No,
snowflakes.
they look white.
Well, that's what I thought too, but bugs can be white.
I don't think it's snowy. I think it's not cold enough.
I don't know. I think I need to get a closer look at this. I don't know. That's definitely bugs, or maybe not bugs. I don't know. You want to come over here?
Slight chance
Oh,
of
no,
rain in
yeah,
the next
it's tree
hour.
stuff.
Is what? Huh?
It's tree stuff. I think.
I don't know. Minor details.
Either way, I wouldn't really want to have to drive home in snow. It's a good thing I don't live far though.
It won't be that
Why
bad.
did you just pick up the sloth by its neck?
He just likes smooches.
That was correct.
Nice. He's raising his hand. Does he have a question?
Maybe. Maybe he was trying to tell on Nathan because Nathan stole something from him. Thief.
Okay, take it back.
Thief.
All right. Use Z calculations. The formula is Z is equal to X minus mu over sigma. The area under the curve is also the probability that the variable is in the interval. If the distribution is normal, use normal model calculation methods.